This is the Algebra 1 lesson on Chapter 6, Section 1, Simplifying Fractions. Okay, so today we're going to talk about how to simplify algebraic fractions. Now, these methods require that you're really strong with factoring. So if you end up maybe not being so sure about some of the factoring methods that you see in the video, I would say go back and review and make sure everything's good. We're also going to learn some new words, rational expression, domain, and simplest form. Okay, so let's start with our warm-up. You're going to factor each expression below. You might want to pause the video and restart it when you're ready. I will show the answers in 5, 4, 3, 2, 1, now. Okay, so hopefully these went well for you because these are key methods that we're going to use for the algebraic fractions coming up. Let's start by defining simplest form. Okay, so if the numerator and the denominator of a fraction have no common factors, we call this simplest form. For example, 42/60 is not in simplest form because 42 and 60 have a common factor of 6. However, on the other hand, 37/60 is in simplest form because 37 and 60 don't have any common terms. Okay, so the simplest versions of rational expressions are fractions, your old buddy from primary school. But now we're going to introduce variables in our numerator and our denominator, so we have to make some adjustments for what is actually allowed as values of our variable. So you might remember that 0 over any number is 0, and the number over 0 is undefined. So we have to make this adjustment in our rational expressions so that our domain excludes any values where your denominator equals 0. So the way we do this is we find our excluded values by just setting our denominator equal to 0 and then using the zero product property. So in order to simplify rational expressions, we have to do the following. Completely factor our numerator and our denominator, we restrict our variables, we cancel the common factors, and then we simplify. All right, so example 1, simplify the fraction below, and we need to provide restrictions on our variables. So 3a over 3a plus 3b. So our first thing we do is we factor the numerator and the denominator to get 3 times a plus 2 over 3 times a plus b. The second thing we're going to do is restrict our variables. Very important that you do this second. Factor, then restrict, okay? So I look at my denominator. 3 times a plus b must not equal 0, which means a cannot equal negative b. Now that my domain is restricted, I'm going to cancel my like terms. So 3 and 3 cancel, and then I simplify. Now I simplify, take my a plus 2 over a plus b, and then I hold on to that restriction. That needs to be a whole part of my answer. Okay, feel free to pause the video and try this one on your own. We need to do the same thing, but it's with x squared minus 9 over 2x plus 1 times 3 plus x. Okay, first step, always factor our numerator and our denominator. We get x plus 3 times x minus 3 over 2x plus 1 times 3 plus x. Then we're going to restrict our domain. Let's look for our excluded values. Great, we're going to use the zero product property here, setting our denominator equal to 0 and then setting each factor equal to 0 to get that x cannot equal negative 3 and it cannot equal negative 1/2. Now we have our restriction on our domain, so we can cancel any common factors. X plus 3 and 3 plus x are same, so we cancel and leave 1. That leaves us with x minus 3 over 2x plus 1, and we keep our domain restriction there. We're boxed and ready to move on. Okay, you might be ready to try this one on your own, but if you're not, we're going to start now. Okay, so I need to simplify the fraction and give restrictions on the variables. My first step is always factor the numerator and the denominator. I factor to get x minus 1 times 2x plus 3 over 1 minus x times 2 plus x. My second step is always to restrict my domain. 1 minus x times 2 plus x cannot equal 0. I'm going to use the zero product property. And I'm going to see that x cannot equal negative 2 and it cannot equal positive 1. Now that my domain is restricted, I'm looking to cancel any like terms in the numerator and the denominator. But right away, I see that x minus 1 and 1 minus x are similar, but not quite the same because they are opposites. Very good. So I need to rewrite this so that I have a negative sign outside. And now I have a common factor in the numerator and the denominator, and I can cancel x minus 1 for both. Okay. I'm left with 2x plus 3 over negative 2x plus x with my restricted domain. Okay, final example. Solve ax minus a squared equals bx minus b squared for x. Looks complicated? Totally not. First, I move all x terms to one side. I can do this by adding a squared to both sides and subtracting bx from both sides. Next, I factor each side. So my GCF on the left-hand side is x. On the right-hand side, I use the difference of squares. Now, I'm going to isolate my variable x by dividing both sides by a minus b, and I have a rational expression. Rational expressions require that I restrict my domain. So I look at my denominator, a minus b would equal 0 if a was equal to b, so a cannot be equal to b. Oh, that should say b, not negative b. Okay, and now we've restricted, we're canceling our common factors, and we are left with x equals a plus b with the restriction a does not equal b, not negative b. Sorry for the type. All right, so today we learned about how to simplify algebraic fractions, but how would you describe that in your own words? Talk amongst yourselves, and I will see you in the next video.